Hi everyone, I'm going to start a series where we are going to discuss about many question and answers related to class 10th physical science, and this session is going to be useful for Telangana as well as Andhra Pradesh state boards. So now in this class we are going to discuss about many critical questions based on reflection of light on curved surfaces. So in this session I am going to put the question as well as I am going to explain the answer in detail. So whenever you are going to have a doubt, you can pause the video and you can able to listen it again. Okay, let me start the session. So first question is, why the real image is always inverted? Why the real image is always inverted is the question. So let me tell you which mirror can form real image. Only one mirror, that is this concave mirror, is going to form the real image. You all know this is a concave mirror and this mirror can form the real image. And why it is going to form the real image? Whenever the incident ray is going to be fall here, let us take this is the incident ray, and now tell me on reflection it should have to move towards the center. Am I right or wrong? That means towards the principal axis it has to move like this. Then you observe carefully, whenever the ray is reflected, the image is going to be formed below the principal axis. See, this is the portion where the image is going to be formed. Now this is considered as positive y-axis and this is called as the negative y-axis. Now you tell me, as the image is formed below the principal axis, that's why we can say the real image is always inverted. Hope you understand this. Now we are going to shift to the next question, that is, distinguish between real image and virtual image. Distinguish between real and virtual images. So first of all, let me tell you what is the real image. The image which is going to be caught on the screen is what we called as real image, and the image which cannot be caught on the screen is called as virtual image. See, let us take this as a mirror. Which type of mirror it is? It is a concave mirror. You all know that concave mirror can form real as well as virtual images. Virtual image means you have to understand that image is going to be formed here. That means image is formed behind the mirror, then that image is what we called as virtual image. That means virtual image is always erected, real image is always inverted. You have to understand, virtual image is always erected, real image is always inverted. That's why this is the short answer question. You can write the answer as, the image which can be caught on the screen is called as real image. The image which cannot be caught on the screen is called as virtual image, is point number 1. And point number 2 is, real image is always erected and virtual image is always inverted. That's it. That's the answer. Now we will skip to the next question, that is, distinguish between concave and convex mirrors. Okay, so you know this is concave mirror, this is a concave mirror, and you know this is a convex mirror. Okay, so this is a convex mirror. This mirror is called as a convex mirror. This is a concave mirror. Now could you please tell me, this mirror is considered as a bulged inwards. It is bulged inwards. See this is bulged inwards and this is bulged outwards. That's why the first difference is, this is a bulged inwards mirror and that is a bulged outwards mirror. And this is considered as a converging mirror. You know, concave mirror is a converging mirror and convex mirror is a diverging mirror. And this mirror can form real image and it can form virtual image, but convex mirror can form only virtual images. It cannot form real image. And you can write the last point as one of the use. Concave mirror can be used as solar cooker, or it can be used by ENT specialist, and convex mirror is going to be used in rear view mirror in automobiles. Okay, that is the answer. The next one is, write the mirror formula and explain the terms present in it. What is mirror formula? And we are going to explain the terms present in it. So just remember the mirror formula. Just revise what is the mirror formula. 1 by f equals to 1 by u plus 1 by v is called as mirror formula. 1 by f equals to 1 by u plus 1 by v is called as mirror formula. And here we can say f is called as, this is called as focal length. U is called as, this is object distance from the pole. And v is called as image distance from the pole. Okay. So this is the mirror formula. So what is mirror formula? 1 by f equals to 1 by u plus 1 by v is called as mirror formula. And here f stands for focal length, u stands for object distance from the pole, and v stands for image distance from the pole. Now the next question is define magnification and write its formula. Define magnification. So what is called as magnification? It is the ratio of height of the image to the height of the object is called as magnification. Okay. So what is magnification? The ratio of height of the image to the height of the object is called as magnification, and the formula of the magnification is hi by ho is equals to minus v by u. This is called as magnification formula. So we can write the formula as m stands for magnification is equal to hi by ho is equal to minus v by u. This is called as magnification formula. We'll skip to the next one. Now, one by one, we are going to understand what are the technical terms that are going to be involved in the concept of mirror. Okay. Now, see, we'll discuss. Now, you can easily understand this is called as a concave mirror. Here, this point is called as pole. This is called as F. And this is called as C. You remember KFC? No, not that KFC. This is PFC. Pole, focus, center of curvature. This is pole, this is focus, and this is center of curvature. So what is called as pole? The geometrical center of the mirror is called as pole. And the distance between P and C is what we called as radius of curvature. And half of the radius of curvature is called as focal length. So focal length is nothing but half of the radius of curvature, or we can say r is equal to twice the focal length. This is also considered as a very important question for us. That is relation between f and r is f is equals to r by 2, or we can write r is equal to 2f. Okay, these are the most terms that we are going to use. P, F, C. P stands for pole, F stands for focus, and the distance between P and F is called as focal length. Okay, let us assume that we have placed the object here. This is the object. Then distance between pole and object is what we called as U. Let us consider the image is going to be formed here. Now, distance between P and I is what we called as V. Hope you understand. You have to understand what is called P, F, C, U, V, F. All these technical terminologies you have to understand. Okay. Once it's right, then it is going to be easy for you. Now we'll skip to the next question. That is, write the rules of sign convention. Okay. This is a very important question. While solving every problem, you are going to use sign convention. And I'll tell you the simplest way of learning sign convention. Okay. Now try to listen. If you don't know what is sign convention, you need not to worry at all. Now within 1 minute you are going to understand sign convention. Now could you please tell me what type of mirror it is? It is a concave mirror. This is called as P, this is called as F, and this is called as C. Now try to understand. For the concave mirror, in which side you are going to place the object? See, this portion I can't place the object because that is silvered. Now the only side is this That means in this entire area I can place the object. So in which direction you are placing the object, that is called as minus, opposite is called as plus. Just remember this. That means you are placing the object here, 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 wherever you are going to place the object, this entire thing is going to become negative. Now could you please tell me where is f? This is f focal length. This is also falls under this, that's why f is also become negative. So f for concave mirror is always negative. U for any mirror is always negative. Now the question is about V. If V is also falls under this, it is also become negative. If V comes under this, then it is going to become positive. Now let us see the same thing for the convex mirror. See, this is convex mirror. Now could you please tell me where you are going to place the object? This is P, this is F, and this is C. Obviously you are going to place the object this side because this side is silvered. That's why you can't place the object here. You have to place your object here. Now it is going to become minus. This is going to become plus. Now tell me for convex mirror, F is always positive. U for any mirror is always negative. V for the convex mirror, as V is always formed this side, it is also going to become positive. You note these points. Okay. So what are rules of sign convention? The first rule is distances should always be measured from the pole. The second one is the direction of the incident ray is always taken as negative. Opposite to that is taken as positive. Rule number 3 is about the height. If object, wherever you are placing the object, if image is formed like this, then its sign is negative. If image is formed like this, then its sign is positive. That means if the image is erected, its sign is positive. If the image is inverted, its sign is negative. That's it. These three are called rules of sign convention. The first one is distances are always measured from the pole. The second one is the direction of the incident ray is always taken as positive. Opposite to that is taken as negative. Rule number 3 is if the image is erected, its sign is positive. If the image is inverted, its sign is negative. Now we are going for the next question. So next question is, let me tell you, draw the ray diagrams for the concave mirror. So first of all, what are the different situations are there for the concave mirror? Once again we are going to revise. This is a concave mirror and this is called principal axis. Let me locate P, F and C. Now for a concave mirror there are 6 conditions are there. That means at 6 different positions we can place the object. The first one is we can place the object at infinity. That means somewhere like sunlight, moonlight, some longer distance. The second one, we can place the object beyond C. The third one, we can place the object exactly on C. The fourth one, we can place the object between F and C. The fifth one, we can place the object on F. And the sixth one, we can place the object between P and F. That means for a concave mirror, how many conditions are there for placing the object? 6. What are they? At infinity, this is the situation. Beyond C, on C, between F and C, on F, between P and F. So now we will discuss one by one. The first one is what happens when we are going to place the object at infinity. Now we are going to look at the ray diagram. This is P, this is F and this is C. You should understand that whenever we are going to place the object at infinity, you have to understand that these rays should be parallel rays only. That means rays are parallel to the principal axis. See, like this. These are the incident rays which are parallel to the principal axis. So according to our rule, if the incident ray is parallel to the principal axis, reflected ray should pass through F. That means all the reflected rays should have to pass through F. See, this is the place where the image is going to be formed. Now could you please tell me where the image is formed? Image is formed on F. And remember, it's a real image. See, we are going to place a paper here, then the piece of paper is going to burn because all these are converging rays. This is our first situation. And second situation, what is our second situation? Now we can place the object at beyond C. P, F, C. I am placing the object here. Let us take this is the object. The first one, if the incident ray is parallel to the principal axis, it should have to pass through F. Second one, we can use this angle of incidence at the pole is equal to angle of reflection at the pole. That means it is the place where the image is going to be formed. Could you please tell me where the image is formed? Image is formed between F and C, and it is a real image, but it is a diminished image. That means size of the object is more and size of the image is less. These are the two conditions. Now we are going to go for the third condition. What is the third condition? We are going to have what happens when the object is placed on C. See, this is the condition P, F and C, and we are placing the object here. This is the object. Okay, first one, parallel to principal axis, should have to pass through F. Angle of incidence at the pole is equal to angle of reflection at the pole. That means where the image is formed, image is also formed on C, and you have to understand that size of the object is equal to size of the image. That means neither enlarged nor diminished image is going to be formed. So whenever we are going to place the object on C, image is also going to be formed on C. Here you can understand about another question. In a concave mirror, if the object is placed on C, then we are going to have the image exactly formed on C, and size of the object and size of the image both are same. That means if the object is of 5 centimeters height, then obviously the image is also going to be 5 centimeters. Now the next condition is, we are going to place the object. Okay, this is P, this is F and this is C. Now we are going to place the object between F and C. Okay, same conditions, parallel to principal axis, should have to pass through F. Angle of incidence at the pole and angle of reflection at the pole. Now you can clearly understand where the image is going to be formed. Image is formed beyond C, and remember, size of the object is this and size of the image is bigger. That's why obviously we are going to have a enlarged image in this condition. Now the next condition is what happens when the object is placed exactly on F. See, this is a concave mirror. This is P, F and C, and here we are going to place the object on F. See, the first one, parallel to principal axis, should have to pass through F. Angle of incidence at the pole is equal to angle of reflection at the pole. Now it is clear that they are neither going to intersect this side nor this side. That's why they are not going to intersect. That's why we can say that image is going to be formed at infinity. In this case, image is formed at infinity. Now for the last condition, this is a concave mirror. This is P, F and C. What happens when the object is placed between P and F? Parallel to principal axis, should have to pass through F. Angle of incidence at the pole is equal to angle of reflection at the pole. Now it is clear that they are not going to intersect this side, but if I am going to extend this, now these two are going to intersect this side. That means behind the mirror. This is the place where the image is going to be formed. This type of image is what we call as virtual image. And this is a enlarged image too. Virtual and enlarged. That means concave mirror can form virtual image in only one condition. What is that condition? Between P and F. It is virtual and enlarged. So these are the 6 ray diagrams for the concave mirror. Now we are going to look after the ray diagrams for the convex mirror. See, unlike concave mirror, we need not to go for all the 6 conditions. We don't have 6 conditions in fact. Now we are going to see this is a convex mirror. P, F and C. See, obviously you have to place the object this side. You can place condition number 1, that is object can be placed at infinity. Condition number 2 is anywhere between infinity and P. Anywhere in between them. Now first condition. Remember, this is a diverging mirror. Now this is P, this is F and this is C. Now I told you already, whenever we are going to place the object at infinity, you are going to have parallel beam of light. See, it's parallel beam, not chota beam. Okay, parallel to principal axis. Now it is considered as a diverging mirror. It is diverging here, diverging here, and on the principal axis it will bounce back. It is diverging here and it is diverging here. Then obviously where the image is formed behind the mirror, exactly on a highly diminished point image is going to be formed in this condition. For the second condition, again this is a convex mirror. This is P, F and C. Let us consider the object is placed somewhere between infinity and P, parallel to principal axis, should have to pass through F virtually. Angle of incidence at the pole is equal to angle of reflection at the pole. It appears to be coming from backside of the mirror. Now you can understand this is the place where the image is going to be formed between P and F, that is behind the mirror. In both the cases we are going to have erected images. We are going to have erected images and we are going to have only diminished images. That means concave mirror can form real image, virtual image, enlarged image, size of the object is equal to size of the image and diminished image. But a convex mirror can form only diminished image, only erected image, only virtual image. Always diminished, always virtual, always erected. You remember this. This is for the convex mirror. Okay. Now we are going to understand what are the rules of drawing the ray diagrams. See, while we are going to draw the ray diagrams, we have to keep certain things in our brain. So what are the things? The first one is whatever the type of mirror it is. Let us take a concave mirror as an example. You know, this is P, F, C. The first rule says if the incident ray is parallel to the principal axis, then reflected ray should pass through F. This is our first rule. Okay. If the incident ray is parallel to the principal axis, then reflected ray should pass through F. And the second rule is also this, the converse of the statement. Okay, let us take, this is the incident ray now. If the incident ray passes through F, then reflected ray will be parallel to the principal axis. These are rule number 2. What is rule number 1? If the incident ray is parallel to the principal axis, then reflected ray should pass through F. Rule number 2 says if the incident ray is passing through F, then the reflected ray will be parallel to the principal axis. Now rule number 3 is very easy. If the incident ray passing through principal axis, then reflected ray bounce back onto the principal axis. And rule number 4 is angle of incidence at the pole is equal to angle of reflection at the pole. That's it. These 4 are called very, very important rules of drawing the ray diagrams. Okay. Hope you understand. If you don't understand, you can pause the video and you can listen it again. The next one, we will draw some of the ray diagrams. That means we are going to understand about a ray diagram has been given to us, but it is an incomplete ray diagram. We have to complete it. Okay, it is a very, very important question for us. P, F and C, and the question is given like this. That means he kept the object like this and he is asking us to complete the ray diagram. Now could you please tell me what type of mirror it is? It is a concave mirror where the object is placed between F and C. The first one is parallel to the principal axis, should have to pass through F. Angle of incidence at the pole is equal to angle of reflection at the pole. That means you can clearly understand where the image is going to be formed. Now could you please tell me where the image is formed? Image is formed beyond C. This is an enlarged image and it's a real image. Now the second one is, in this case he has again given a concave mirror. This is P, F and C and he placed the object here. That means beyond C, second condition. Parallel to the principal axis, should have to pass through F. Angle of incidence at the pole is equal to angle of reflection at the pole. That means it is the place where the image is going to be formed. It's a diminished image, a real image. It's a real and diminished image is going to be formed. Whenever we are saying real, you have to understand it is inverted. Whenever saying virtual, that means it is erected. Whenever we are saying Ram, we will say Lakshman. Okay, like that. Real and inverted, virtual and erected, like that. Okay, we'll skip to the next question. That is, describe an activity to find the focal length of a concave mirror. How do you find the focal length of a concave mirror is the question. Okay, hope this is a very, very important lab activity and it's a 6 marks question. First of all, we have to write our aim. So what is our aim? Aim is to find the focal length of a concave mirror. To find the focal length of a concave mirror, and afterwards we are going to write what are the materials required to conduct this experiment. What we require? We require a V-shaped wooden stand. We require a concave mirror. We require a meter scale, candle, screen and a pencil to note the values. Okay, have I forgot anything? Okay, now we are going for procedure. So what is the procedure of conducting this experiment? Okay, the procedure, the first one is we are going to draw the diagram. So okay, this is a concave mirror and it is a meter scale, and here somewhere we are placing the candle. Have I written candle? Yes. Now this is the candle and here somewhere we are going to place the screen, and here we are going to have the image. Okay, now you know this distance is what we called as U and this distance is what we called as V. So in the procedure we are writing, arrange the equipment as shown in the figure, adjust the position of the candle such that we can have a clear image on the screen, measure the distance between the mirror and the screen as mirror and the candle as U, and measure the distance between the screen as well as the mirror as V, and you are going to place the candle at different positions, and every time you are going to change the value of U, then obviously the V value is going to change. Then what we are going to do here is we are going to note the values in a table that we are going to write by the means of observation. So what is our observation? In the observation we are going to draw a table. Okay, just draw the table, that's it, need not to mention the values. The first one is serial number. Here we are going to write U, here we are going to write V, here we are going to write 1 by U, here we are going to write 1 by V, in the last we are going to write 1 by U plus 1 by V. Okay, so afterwards, after observation, what we are going to write? After observation we are going to write the result analysis. So what is our result analysis? Okay, can I write here? After observation we are going to write what is our result. So what is our result? From the above experiment we can understand 1 by U plus 1 by V value will remain constant. 1 by U plus 1 by V value will remain constant. Okay, afterwards we are going to write generalization. What is our generalization? From the formula 1 by f is equals to 1 by u plus 1 by v, we can find the focal length of any given concave mirror. So he will ask you sometimes, so what happens instead of concave mirror if you are going to take convex mirror? Can we find the focal length by this method? Sorry, by this method you can't able to find, because you can find the value of u but you can't find the value of v by this method, because convex mirror can form only virtual images and you can't able to measure the virtual image distance, right? Okay. So sometimes he will ask you, what happens if all these materials has been not given to you? Only you have been given a concave mirror, only concave mirror has been given to you. Without doing this experiment, how can you find the focal length? Yes, we can find the focal length. Take this concave mirror in the presence of sunlight, and this is a mirror, and here place a piece of paper. Now all the rays are going to converge at a point and the paper is going to start burning. Now take a scale and measure the distance between these two, is going to give the value of f. It is easiest. Okay, now we are going for the next question. Okay, so whenever you are writing lab activity, try to write in this method. This is very impressive. Okay, so the next question is, why a convex mirror is used as rear view mirror? Could you please tell me? Okay, can you please tell me what is the use of a rear view mirror? Okay, in automobiles or in the bikes, we are going to have a mirror here. Through this mirror, we can able to find whatever the objects are going to become behind. Okay, we can able to find them. So what happens if I am going to use a concave mirror instead of a convex mirror? See, it will form a real image. That means we can't able to catch the image on the mirror. If we are going to use a convex mirror, the advantage is it always forms a diminished image. That means total image we can see here only, and it will form a virtual image. Virtual means, I told you already, it is erected image. Means the desired thing is it should be a diminished image, it should be virtual, it should be erected. Now you only suggest me which mirror is to be used, convex or concave. Obviously your answer is should be convex. Now we'll go for the next question. Magnification values. This is a very important question for you. Please try to understand what I am saying. Okay, because in many examination this question was asked. So if magnification value has been given to you, now you have to find which mirror it is. After finding the mirror, you have to tell what is the position of the object, where the object is placed. I'll tell you one thing. See, if whenever you are seeing minus in front of magnification, plus in front of magnification, what does it mean? If magnification is minus, it means the image is inverted. If magnification is plus, that means image is erected. Whenever you are seeing minus, your answer should be concave mirror only. Whenever you are seeing erected, your answer may be concave mirror, convex mirror, or plane mirror. That means again we have chance of 3 mirrors. Okay, erected means you just have to stop and think. If it is inverted, no need to think, it is concave mirror only. And again, if the magnification value is less than 1, that means the image is diminished. If magnification value is exactly 1, then size of the object is equal to size of the image. If magnification value is greater than 1, that means image is enlarged. Okay. Now by using this data, now we are going to solve certain types of questions. See, for example, the magnification value is given as 0.72. What type of mirror it is? Where the object is placed. See, one thing is clear. By looking at this plus, we can say it is erected. Okay, divide it like this. 2 parts, symbol and number. 0.72 value is falls under this category, that is minus 1. Sorry, less than 1. Less than 1 means diminished. See, erected diminished will be formed only by convex mirror, because erected can be formed by concave also, but that erected is enlarged, not diminished. See, for example, you have been given -7 is the magnification value. Now divide it into two parts. Minus means, tell me, this is inverted. 7 means falls under this category, that is enlarged. Now could you please tell me, inverted means only one choice, that is concave mirror only. Enlarged means the object is placed between F, C and F. Okay, I'll give you another question. -1. See, you have to divide it into two parts. Symbol, number. Minus means inverted. 1 means size of the object is equal to size of the image. So inverted means that should be concave mirror only. And size of the object is equal to size of the image is possible only when the object is placed on C. That's why our answer is very clear. Okay. Now, can you guess what is the magnification value is +1? Then what type of mirror it is? It is erected. 1 means size of the object is equal to size of the image. But don't be confused. Size of the object is equal to size of the image is also condition for the plane mirror. Okay, in the case of plane mirror, you are going to find this. That's why don't be confused. It cannot be concave because here symbol is not minus, symbol is plus. So we can write easily, we can write the answer. I'll give you some questions if you want interested. Okay, you do this, and you solve this one too. Okay, these 3 questions, just practice. Okay, and verify your answer. If possible, comment the answer. Okay, now we'll go for the next question. What's that? Our next question is, find the focal length of a convex mirror if the radius of curvature is 32. Okay, radius of curvature is equal to 32 centimeters. Find the focal length. Okay, now tell me, what is the relationship between radius of curvature and focal length? F is half of radius of curvature. That means 32/2, which is equal to 16 centimeters over. It's the easiest one. And the next one, a concave mirror produces 3 times magnified image, real image of an object placed at 10 centimeters. That means he has given object is placed at 10 centimeters and it is producing 3 times magnified real image. That means magnification value is 3. Real image means minus. Okay, now where the image is located? That means he is asking us what is the value of V. Now tell me, what is the formula for the magnification is equal to HI by HO is equal to minus V over U. Minus V over U. What is the value of U here? Minus 10. I told you already, the object distance is always taken as negative. Then magnification value is minus 3. So minus 3 is equal to minus V by minus 10. Minus get cancelled. V is equal to minus 3 times 10, which is equal to minus 30 centimeters. That's it. 3 times means the magnification is going to become 3. Real image, that's why we have written minus. An object of size 5 centimeters is placed in front of at a distance of 25 centimeters. As given, object height is equal to 5 centimeters. Object is placed at 25 centimeters in front of a concave mirror. So you have to understand, you have to write the data like this whenever you are going to solve a problem. And the radius of curvature is given as 30 centimeters. Radius of curvature is given as 30 centimeters. That means you can tell me focal length is equal to 30/2, which is equal to 15 centimeters. Now the question is, where does the image is located and what is the height of the image? Okay, certain type of questions are very important, 4 marks question for us. Okay, height of the object is given. First we'll look after this U. This is a concave mirror. Okay, this is a concave mirror. Now write P F C. The focal length is 15 centimeters. I told you already, you are going to place the object this side, that's why this entire side is going to become minus, this side is going to become plus. That's why object distance is minus, focal length is also minus. Now we are going to use the mirror formula. What is mirror formula? 1 by F is equal to 1 by U plus 1 by V is called as mirror formula. 1 by F, what is F here? Minus 15 is equals to 1 by U, what is U here? Minus 25 plus 1 by V. Now the next step is 1 by V is equal to, already minus 1 by 15 is there. This minus 1 by 25 is going to become plus 1 by 25. And the LCM of 15 and 25 is 75. 15 in 75. 3 times, sorry, 5 times. 25 in 75, 3 times. So this is minus 5 plus 3, which is equal to minus 2 over 75. Then 1 by V is equal to minus 2 over 75. That implies V is equal to the reciprocal of this, that is minus 75 by 2, which is equal to minus 37.5 centimeters is the value of V. After knowing the V, we have to find the value of height of the image. We have a formula. What is that? Hi by Ho is equals to minus V over U. Put the values there. Hi we don't know. Ho value is given as 5. That's why we are going to write 5 here. Is equal to minus of minus 37.5 over U value is minus 25. Okay, minus will be cancelled. Hi equals to, this is minus 37.5 times 5 over 25. This is 5 times, it is minus 7.5 centimeters. So an enlarged image is going to be formed. Okay, you can take a screenshot out of it. I'll go for the next question. Hope you are understanding the question. Okay, try to solve the problems, because earning marks is very easy for us. A concave mirror of focal length f is equal to 30 centimeters is broken into 3 pieces. Then what is the focal length of each piece? It is really a funny question. So maximum students are going to give the answer as, okay, 30 centimeters is focal length. How many pieces? 3 pieces. That's why each piece is going to have a focal length of 10 centimeters. And remember, you are absolutely wrong. Whatever the focal length of the mirror is there, whether it is convex or concave, irrespective of type of the mirror, its focal length remains constant even if it is broken into n number of pieces. Even it is broken into n number of pieces, its focal length does not change. So what is the answer? Its focal length remains constant, or 30 centimeters only is the answer. And another funny question he will ask you, that if a concave mirror has been immersed into the water, then its focal length increases or decreases. Again, our answer is constant. It does not increase, does not decrease. The focal length of a concave mirror or convex mirror, even if it is kept under the water, will remain constant. Even it is broken into n number of pieces, its focal length will remain constant. Now the next question is, okay, so type of questions are going to be asked in the examination. You should be very cautious. Especially you are going to be confused when 20 centimeters focal length is given and broken into 2 number of pieces. Then 20 by 2, don't write like that. Okay, answer will be 20 centimeters only. Even it is kept in water, its focal length increases. No, it won't increase, it won't decrease, it will remain constant. An object is placed at a distance of some focal length is 20, placed at a distance of 10 centimeters. That means u is equal to 10 centimeters. Focal length is equal to 20 centimeters. Where the image is going to be formed? It's a concave mirror. It's a concave mirror. Okay. Now guess. You solve this problem, okay, by using the formula 1 by f is equal to 1 by u plus 1 by v. We are going for 1 by v is equal, it is going to become 1 by f minus 1 by u. 1 by f is going to become minus 20 according to sign convention. This is minus 1 by u. U is going to become minus 10, so it is minus 10. So minus 1 by 20, minus of minus is going to become plus. This is 1 by 10. LCM of 10 and 20 is 20. 20 in 20 one time, 10 in 20 two times. So it is going to become minus 1 plus 2, which is equal to 1 by 20. Then V is equal to 20 centimeters. Okay. Right, next one. Which mirror is called as driver's mirror? Okay, which mirror is called a driver's mirror? That means obviously it should be a rear view mirror. Which mirror is called as a rear view mirror? Convex mirror is called as rear view mirror. So our answer is convex mirror. And next question. A burning candle is placed at 20 centimeters in front of a concave mirror of focal length 20 centimeters, 10 centimeters. So placed U is given as 20 centimeters and F is 10 centimeters. Then where the image is going to be formed? Try to guess. Okay, this is a concave mirror. This is P, this is F, this is C. And object is placed exactly, this focal length is 10, then obviously it is also going to become 10, then this is 20. So object is placed on C. If object is placed on C, then image is also going to be formed on C. Your answer should be V is equal to 20 centimeters only. In fact, you will get minus 20 centimeters once you solve it. Okay. And one more question I just want to discuss with you. This is a concave mirror PFC. And once I saw this question in textbook, I think, what is the minimum distance between real object and real image? What is the minimum distance between real object and real image? Okay, let us assume that object is placed on C, then where the image is going to be formed? Exactly on C. Now this is real object and it is real image. What is the distance between them? 0, because both are formed on C. That's why the answer should be 0. So I have discussed many questions, but obviously if you are going to have any doubt regarding to any question on this topic, please do message me. So I'll try to clarify in the next session. Hope you understand the lesson and enjoy the concept. Thank you.